my eyes just went up to the canopy, to the treetops, as I think all of our eyes do when we go into a forest, where our eyes and our spirit are drawn upward. And I began seeing these, plants, orchids, ferns, bromeliads, and birds that were high above the forest floor. And I asked my professors, like, what is going on up there? Shouldn't we be up there studying where sunlight turns into leaves and stored energy, and where birds are interacting and monkeys are running around and plants are reproducing? And they said, well, Nalini, we don't know how to get up into the canopy. We don't really know much about it. There's really no research that's gone on. In fact, the canopy at that time was called the last biotic frontier. And, when I realized that, I thought, well, that's my job, isn't it, as a scientist, is to pursue studies of what is not known. And here was a very clear area of the forest, which I love.
I'm Brandon Vaidyanathan, and this is Beauty at Work, the podcast that seeks to expand our understanding of beauty, what it is, how it works, and why it matters for the work we do. This season of the podcast is sponsored by John Templeton Foundation and Templeton Religion Trust. My guest today is Dr. Nalini Nadkarni, an ecologist who pioneered the study of rainforest canopies and who is one of the country's leading science communicators. Nalini has authored more than 150 scientific papers and several books on the composition and ecological roles of canopy-dwelling communities. In her science communication efforts, she engages regularly with artists, faith-based groups, corporations, and people who are incarcerated. In 2023, the National Geographic Society named her as one of their 10 explorers at large. Her awards include a Guggenheim Fellowship, the AAAS Award for Public Engagement, the National Science Foundation Award for Public Service, the Rachel Carson Award for Conservation, the William Julius Wilson Award for Advancement of Social Justice, and the Archie Carr Medal for Conservation. In this episode, we talk about how trees can evoke our profound yearnings for connection to nature, for making a contribution, and for a sense of home. Let's get started. All right, Nalini, thanks for joining us. It's such a pleasure having you on the podcast.
Sure, I'm glad to be here. Thank you, Brendan.
Great. Well, the last time I saw you, we were at this lovely dinner that I'd hosted in Utah on beauty, and we were talking about stories of childhood experience of beauty. And I really was struck by the story you shared of one of your maybe early memories of encountering beauty, and particularly the beauty of trees. And I'm wondering if you could share that story with us.
Yeah, sure. Well, I grew up in Bethesda, Maryland, in suburbia, but my parents had a home that had these 8 maple trees that lined the driveway. And for some reason, as a kid, I just really glommed onto those trees as there being my place. I had 4 brothers and sisters. We had sort of a chaotic household. My dad is from India, a Hindu, a scientist. My mother's from Brooklyn, New York, an Orthodox Jew. And so we had pets and chores and homework. And so those times in the trees, when I would go out and choose one of the 8 maple trees after school to climb, became kind of my place. My siblings didn't get up there. Certainly my parents didn't get up there. And so I think I started climbing it almost as a refuge, as like, okay, I need to get away from the house for a little while. But I think there was also a time, a moment that I described to you and the others at that dinner, where I was struck not only by, a treetop as an escape, but a treetop as a place, and a place of curiosity, of beauty, of refuge, of offering others refuge. And, I remember this moment in the fall where the leaves, I realized, were dancing. They were creating their own dance of moving from the top of the tree through the wind, scarlet gold leaves moving to the ground to create this river of gold on our driveway, covering the gravel of the driveway. And it struck me then, and that moment has stayed with me throughout my long, long life of working with trees, that trees are places of all of those things: refuge, beauty, offering of help, and a sense of place. And I guess for me, since I was the only one who climbed trees, there was a sense of self. There was a sense of, this is my place. This is where I belong. This is where I am protected by being held by the strong limbs of these trees. And maybe some of that was missing in other parts of my life for different reasons. But that's why I did take a little oath when I was 8 or 9 years old of saying, well, trees have been great for me. And when I'm a grown up, I want to do something that will help protect and be a refuge for trees as well.
Wow.
And those threads have continued because I think they were laid down in such a a strong way when I was a little kid, as I think as so many grown-ups end up doing things that originated in their childhood. I don't think I'm unique at all in that regard, but that sure was a strong dose of treedom that helped me move towards who I am now and what I've chosen to
Wow.
do.
Wow, that's extraordinary. And yeah, I mean, I think it's true about encountering beauty. There's philosopher Elaine Scarry says when we encounter beauty, something that's beautiful, we want to protect it, we want to share it, we
Yeah.
want to preserve it, and make sure it's available to others and so on, right? And particularly, I think encountering the beauty of nature is one of those things that moves us. So how did this like when you were young, did you say I want to go and become a biologist, or
Well,
like what
that's
shaped
really
your
funny, Brandon. When I was a little girl, and especially I was a little girl, back in the 1960s when there were not that many women role models in science, I'm afraid. And I was not even aware of, I didn't become aware of the field of ecology until I went to college and took my first, biology 101 class. And there was an ecologist talking about how people can just sit and observe nature and make a living doing it. So when I was that 8-year-old girl, I thought, oh, if I'm going to protect trees, I'm going to have to become a firefighter or a forest ranger or something that would help me directly protect trees. And as I said, it wasn't really until college and my encounter with higher education and academics that I became aware that we can help and protect nature by understanding it, by doing research on it, by sharing that knowledge with others, and by promoting good management or good stewardship of trees through our increased knowledge of trees. And so it really wasn't until college that I realized that would be a potential pathway for me to fulfill that childhood oath of protecting trees.
Wow. And then you went on to become one of the pioneers in the study of tree canopies, right? Could you talk about what that was like, the beginnings of that field, and how do you sort of embark upon studying something that no one pays attention to, or
Well, again, many people who are pioneers in their fields understand this. I think for me, it came, certainly from this love of tree climbing and this desire to do something for trees and forests. And at that time, this is the beginning of graduate school where, as you know, everyone who goes and gets a PhD has to pick some sort of specialty within that general field. And I was on a field course in Costa Rica that was offered by a group called the Organization for Tropical Studies for graduate students to introduce them to the field of tropical ecology. And I remember very well the first walk that we took through the tropical cloud forest of Monteverde, Costa Rica, where I've ended up doing pretty much all of my research since then. My eyes just went up to the canopy, to the treetops, as I think all of our eyes do when we go into a forest, where our eyes and our spirit are drawn upward. And I began seeing these, plants, orchids, ferns, bromeliads, and birds that were high above the forest floor. And I asked my professors, like, what is going on up there? Shouldn't we be up there studying where sunlight turns into leaves and stored energy, and where birds are interacting and monkeys are running around and plants are reproducing? And they said, well, Nalini, we don't know how to get up into the canopy. We don't really know much about it. There's really no research that's gone on. Wow. In fact, the canopy at that time was called the last biotic frontier. And, when I realized that, I thought, well, that's my job, isn't it, as a scientist, is to pursue studies of what is not known. And here was a very clear area of the forest, which I loved. It involved climbing trees, which I loved. And so it turned out to be sort of the perfect matrimony between what I wanted to find out about for the sake of filling holes in science and illuminating the black box of what was then the forest canopy with the activities that I actually was sort of preconditioned for. And so there was some resistance, just from my own academic graduate committee saying, well, there's no literature on the canopy. We don't know anything about it. It's going to be impossible to get funding for canopy work. It's just Tarzan and Jane stuff. But I sort of persisted. There was some intuitive sense, I think. And although many scientists, including myself, sometimes dismiss intuition as a way of doing science, we believe in testing, hypotheses based on facts. There was something intuitive about, I think I need to at least explore the possibility of this as an area of research, that then motivated me to learn about tree climbing and mountain climbing and, getting myself up there safely and non-destructively. And beginning some very, very preliminary, very basic research. It was really 19th century research of descriptive work. It wasn't experimental. It wasn't modeling. It wasn't all this new stuff that was going on in science. It was like who's up here? How much does it
Yeah.
weigh? What is it made of? How much nitrogen is stored up here? It was these really stupid, simple
Yeah.
questions that had to be laid down first, which then led and provided the foundation and the groundwork, so to speak, of doing more sophisticated work with experiments, with removing epiphytes, with understanding external disturbances like climate change and invasive plants and isolation and so forth. That those are the questions that I'm working on with my students now. But back then it was really, it was pith helmet basic research of
Wow.
who's up there and what's
Yeah.
going on.
How do you get up there? What does it take to, could you describe for us, like, what is?
Yeah, sure. Well, there are many ways to get up there now. The early canopy researchers actually didn't go up in the canopy at all. They used fogging devices to study, say, insect diversity. So they would shoot up this insecticidal fog, harmless to humans, but deadly to insects. It would get into the canopy and these insects would die and sort of rain down and end up in the funnels of these collectors. But I really wanted to get up there. It was really, to me, it was like the longing of marine biologists to study the benthos, to study marine organisms, where they live, where they behave, where they reproduce, where they interact in the environment where all of that is going on. And scuba gear was invented, and they were able to really look up close and personal, not just what are the organisms. I mean, you can dredge those up really easily, but to understand what's going on with behavior in the environment where they're living was really important to me and to other canopy researchers. And so we adapted just very simple mountain climbing techniques, treating a tall tree like a tall mountain or a tall rock cliff. We shoot lines up into the forest canopy, a little thin fishing line with a slingshot or a crossbow or an air gun that goes up and over the branch. We then tie a nylon cord, a 1/4-inch nylon cord to that. We pull that in up and over the branch, and then we tie just a standard 9mm climbing rope. That goes up and over the branch. We tie one end of that off to the trunk. We put on our climbing harnesses that you can get at REI. And there are these little devices called ascenders. We have one for our hands and one for our seat harness, and we alternate moving those up and down the rope. And so you can basically inchworm up the rope, not hauling yourself up with the strength of your arms, but basically standing up, sitting down, standing up, sitting down until you've climbed the rope and you can get access to the branches above you. So it's fairly inexpensive. It's fun. It's not destructive to the tree because all you're doing is putting a line up there. You're not putting spikes in there the way the very early researchers used to do. And so you can put it all in one backpack and there you are. And since then, we've also applied other ways of viewing the canopy with walkways from one spot to another. We've been using construction cranes and installing those into old growth forests. There's 17 of those construction cranes that now exist around the world. The French developed a way to use hot air balloons to get up into the forest canopy. Very expensive, and you can't use them in windy places. So they're not very practical, but they sure look great. So really, I would say, and now, of course, we have a whole array of remote sensing tools. So we can use imagery from space. We can use drones. Those are being used now to fly over at a lower level. We have LiDAR, which is a sort of radar that bounces off the forest floor as well as the treetops. So I would say, and amazingly, in the last 40 years, just the course of my own career, I've been able to observe the development of these canopy access techniques that now make canopy access just super accessible, super safe, non-destructive, and allows us to ask a range of scientifically and socially important questions about forest canopies.
Yeah, that's amazing. I an image that comes to mind is from the Hobbit movie. I don't know if you've seen this, but it's when after the Lord of the Rings, there was the Hobbit trilogy, and there's a scene where Bilbo, I think, climbs all the way up to the top of the trees in this dark Mirkwood forest, and it's this whole other world of new species and light. And what was do you recall an early experience or your first experience of being actually on the forest canopy, and what was that like?
It was exactly like Bilbo. We're like, what? Because from the forest floor, you're looking up at this basically invisible. You see the bottoms of the branches, and then you see some green stuff, and then you see birds sort of flopping around. But when you're sitting up in the canopy on one of these large beautiful horizontal tropical tree branches that are covered with this upholstery of diverse orchids and ferns and bromeliads and piperaceae and then this underlying canopy soil underneath those plants, you realize, my gosh, and in the canopy soil are earthworms and larvae and beetles and mycorrhizae and fungi. And so what you're really seeing is this universe of arboreal life that is completely invisible to those who are walking on the forest floor. So I guess in terms of a sense of longing, when we climb into a tropical or temperate rainforest canopy, we satisfy a longing not only for self and connection, we're also, I think, satisfying this idea of curiosity, of discovery, of encountering a world that we were not aware of. And for human beings, I think that's both exciting and fulfilling because it means there's something beyond what we normally see, what we normally know, what we normally encounter. And how beautiful is that?
Yeah. So what surprised you in your research? I imagine there were a lot of pioneering discoveries that you all made, but are there things that stand out to you in particular as, that maybe the challenged received understanding at the time?
Yeah. I'll tell you a really good example, Brandon. And I think this actually goes to a category of longing I think about with trees, which is the longing to connect. And of course, trees themselves are connectors, because they connect the soil with the heavens, right? In fact,
yes.
Tagore, he wrote this wonderful tiny little poem, "Trees are the earth's endless efforts to speak to the listening heavens." And so when I get ready to climb a tree, I note that I'm on the soil where the roots are, where the water is, where the nutrients in the soil are. But as I ascend up the trunk and go up into the forest canopy, I'm moving into this other space, which is connected to the atmosphere, and in turn, the atmosphere with its rain and its water and mist and cloud and the nutrients that are dissolved in those droplets, they get connected to the soil because the plants and the leaves and these canopy-dwelling plants intercept that water and nutrients and funnel them back down to the ground. So trees themselves are these amazing connectors between earth and sky. But one of the discoveries that I made early on in my career made that longing to connect even more concrete. And I'll tell you what happened. So as I said, when I was starting out my work, I was just really asking these stupid basic questions like how much material of these canopy dwelling plants is up there? What's their biomass? And what's their nutrient content? What are they storing up there? And so to answer that question, I had to cut off mats of these canopy dwelling plants and their accompanying soils, and drop them to the forest floor. And then I would dry them and weigh them and grind them up and do the analysis and then extrapolate out to here's how much biomass is in the forest canopy. Well, as I was pulling those mats of living plants and this canopy soil that accumulates under them that are comprised of the dead and decomposing leaves and stems of the plants that live up there, I began seeing these roots. Roots? What are these roots doing here? They did not belong to the mosses and lichens that lived up there. This is in the temperate rainforest of Washington State. And so I began tracing these roots, and it turned out that they would end up starting in the branches and trunks of the host tree, of the maple trees that I was climbing. And I went like, wait, what? Roots are supposed to be down in the ground. But it turned out as I kept on pulling these mats up that there were these networks of living roots that belong to the tree. And the tree actually puts out these roots high above the forest floor, 100 feet above the forest floor, into these mats of canopy dwelling plants in their soils. And so I went, I took samples of them and I showed them to my major professor and I said, hey, what's with these arboreal canopy roots? And they said, like, what are you talking about? Those can't be roots. And I said, yeah, they are. And so I rented a chainsaw the next time I went to my study site and I hacked off these roots to show that they actually did originate in the tree trunk itself. And I plopped them back on my major professor's desk and I said, these are the roots I'm talking about. Well, it turned out nobody had ever discovered them before. And as I began looking at other tree species, I realized, whoa, this is a generalized phenomenon that's going on, that where there's a connection between the plants that get their nutrients from the atmosphere. As they die and decompose, they create the soil. The tree becomes aware of that soil and actually gains access to them through these root systems. We carried out experiments with radionuclides. We found that, in fact, they are capable of conducting. They have the same kinds of mutualisms that below ground roots do, like mycorrhizae, like nitrogen fixation. I put my backpack on and traveled to New Zealand and to Papua New Guinea and found out that there are roots in canopy in trees there as well, wherever there are lots of these canopy plants and canopy soils. So it really is this generalized response to the presence of nutrients in their own canopies. And it became kind of this sense of, well, then there's a mutualistic interaction then between these canopy dwelling plants that people just sort of discounted as not being important and the very trees that support them. And so I feel that my interpretation was that there's sort of a shortcut then in nutrient cycling. The tree doesn't even have to wait till these canopy plants fall to the forest floor. They can get a connection, a direct shortcut connection to them directly, even before they fall to the forest floor. And so it exemplified for me then that trees have evolved to be connectors with organisms that aren't even themselves, like these canopy dwelling plants that they're not really related to. In fact, they have to invest something in supporting them because they have to hold them up. And so to me, it was just a super interesting phenomenon, both from the standpoint of science and botany and forest ecology. But it was also, I think, another example of how when we look at nature carefully, when we really observe, when we really ourselves connect to slow down and look at nature, we can see these examples of how, I wouldn't say nature helps each other out. I think nature is still driven by competition, but that what has evolved is a system where there are benefits to the canopy dwelling plants and to the host trees that support them. And we can look at that in our society about how different elements of society are connected to each other, either intentionally or not. But the result is that there's some kind of synergism that's going on.
Yeah, wow. It sounds like in both the cases of getting started with studying tree canopies and then studying this root system or canopy soil, you had to face some obstacles. And what advice do you have? Because a lot of grad students or even postdocs these days would probably hesitate to go against their major professors and say, look, I really want to invest in this area where you're being discouraged by people who are in the know, right? What do you have any recommendations? Like, what does it take? Like, what for you sustained your ability to continue?
That's a great question, Brandon. And what sort of surprises me, especially now when I go back and read my journals and stuff, back when I was 25 years old and was sort of trying to make these decisions and hold my own in I'll just say a pretty much male-dominated scientific community, especially at that time in forestry. There just weren't that many women graduate students. And it sort of surprises me because, I grew up with a dad from India who was very authoritarian, where we were taught not to question authority. We were taught to do whatever dad said we were supposed to do. But there must have been something there that was also, and maybe this is because both my parents were immigrants, that said, when you need to do something, when you know that you have to go somewhere, when you are certain of something, then you stick to it, even if it seems impossible. And I think that's what happened with me. There was some certainty that happened to me when I was in the canopy of that tropical tree, seeing this diversity, seeing the possibilities of illuminating the black box of the canopy that really gave me a certainty to overcome my hesitancy to question authority. And if you don't mind, I'd love to read a little poem, one of my very favorite poems in the world that states that same idea. It's a poem called Wanting to Move. It's by Vijaya Mukhopadhyay, who's a Bengali poet. The reason I love this poem is because it's spoken from the standpoint of a tree.
Okay, great.
It's called Wanting to Move. Continually, a bell rings in my heart. I was supposed to go somewhere, to some other place. Tense from the long wait. Where do you go? Will you take me with you on your horses down the river with the flames of your torches? They burst out laughing. A tree wanting to move from place to place? Startled, I looked at myself. A tree wanting to move from place to place? A tree wanting to move? Am I then born here to die here? Even die here? Who rings the bell then inside my heart? Who tells me to go inside my heart? Who agitates me continually inside my heart?
Wow.
And so I think, that poem is really about, it could be about you, Brandon, trying to look at beauty and bring in all these
Sure.
amazing people. Like, who would think of bringing in scientists and beauty? But there was something in you that said, I need to do this. I'm going to do this, even though it sounds ridiculous. And for me, sitting in that committee meeting when I was 25 years old and trying to convince, Dr. Scott and Dr. Greer, like this was, studying the canopy is a good idea. It was like that tree saying, what is it in my heart? What is it that agitates me to keep doing this? And there's no answer to that tree. There's no answer. And some trees don't do that. Most trees don't do that. Most scientists don't ask those questions about beauty. Most scientists don't need to climb trees. And so I think we just take that as in some of us, in many of us, I think, that there is something that burns, that knells, that bell is knelling inside us, and we have to listen to it.
Yeah. Wow. One of the things that scientists I talk to often say in terms of the rewards of the work they do, at least in terms of the beauty that they find, is that it's not just in the sensory experience, and it's not even in the emotional experience, but it's in the understanding, the beauty of understanding, the grasping of the hidden order of things, the inner logic of things, the bringing to light of that which was hidden. And I wonder whether that was also part of, the animating force for you. And, because certainly there is the pioneering work of, like a Humboldt or someone who's sort of simply mapping out, here's what things are, but then getting into mechanisms, getting into sort of the causes. And how much has that pursuit of understanding been central to your own work? And how much would you say that is an aspect of the beauty that you encounter in your work?
Oh, yeah, absolutely. And I think that's why I chose to be what is called an ecosystem ecologist. I'm not really too interested, I hate to say this, not really interested in taxonomy or naming species or even physiology is not that compelling to me. Like, how does this work and how does this valve in a plant work so that it can signal to shut down the stomata? What really has always intrigued me from that very first ecology lecture back at Brown University when I took my biology 101 class was the fact that ecology is all about understanding systems. It's understanding how one piece of a system interacts with the rest of it. And whether that's the root part, the roots, the below ground part, or whether it's the leaves or whether it's the canopy dwelling plants, doesn't really matter. What you're really asking is, how does a system work? And if you can understand the pieces of a system, the patterns of how stuff is arranged in a system, and what the dynamics are, what are the fluxes and the pools, and what are the processes that govern the size of those pools and the rate of those processes and fluxes, then you can actually start making predictions. You can say, if we remove the mosses from this carpet of plants, what are we going to find is going to happen in terms of interception and retention of nitrate ions? And if we remove the bromeliads, what happens then? And so ecology becomes a symphony of studies whereby we identify and quantify pools and patterns, and then we move on to processes, and we put those together into this time where we might be able to make a prediction. And that's actually where I feel so happy to have been sort of born and raised doing canopy studies, because now I feel like I'm in a position where I can ask some questions that have to do with predictions. If we isolate a tree in a pasture because we've cleared around the primary forest and we've left a few trees for shade for cattle in that pasture, what's going to happen with those canopy plants? Are pollinators going to come out and still pollinate them? Are fruit dispersers going to be able to cross that ocean of pasture and get those fruits and disseminate them? If climate change is extending the length of the dry season and reducing the amount of mist and fog, how is that going to affect the canopy dwelling plants that depend on that? But also, how is it going to affect the trees that support those? And so now my work is really about making predictions based on my work and other people's work, obviously, that have built up a foundation of understanding of pattern and process. And so I think what I'm trying to answer your question about is yes, a resounding yes, because ultimately, although we have to ask and answer these little tiny questions about pattern and process along the way, what's always in our minds as ecosystem ecologists is, what does this mean in terms of the whole? What does it mean when you disturb a piece of it? Does it recover? Is it resilient? Does it compensate? What's going to happen? And if we know enough about that system, we can make useful predictions, not just as scientists, but also for forest managers or for farmers or, for people collecting medicinal plants or whatever. So that to me is the joy. And I guess I could put it in the context of longing as well, longing to understand a system well enough to be able to predict what will happen to it, either as a steady state system or, more interestingly, I think, if you perturb it somehow.
Yeah. Wow. When I first heard about your work and thought about, rainforest, for a lot of people, I suppose the first association is, Amazon rainforest and dangerous creatures and pythons and so forth. Were there any difficulties you encountered in terms of either, dangerous encounters or even falling from a big height, like injury, or what other challenges did you face?
Yeah. Well, I've been working in the tropical cloud forest of Costa Rica and also the temperate rainforest of Washington State, which are pretty innocuous in terms of the dripping poisonous snakes and, bees that attack your hair and so forth. So, and that was kind of part of my choice. I hate to say this also, but I'm not a snake person.
Right.
So lowland rainforests clearly have some dangers in terms of the organisms that you encounter, but cloud forests and temperate rainforests are pretty benign. But of course, when you're, 150 feet above the forest floor, dangling by on a rope no bigger than your, the width of your pinky finger, there's always danger. You're always subject to gravity, unfortunately, or to a broken branch and actually in 2015, I had a really bad fall. It was the only fall I've taken from a tree in my life, but it was an extremely traumatic fall. I had to be medevaced out of the forest. I was in the hospital for 3 months. I had exploded vertebrae and a broken pelvis and broken ribs and traumatic brain injury and a broken fibula, exploded lung. I lost my spleen.
Oh my gosh.
It was really bad. It was a very bad fall.
Oh my gosh.
Happily and fortunately, I was able to pretty much recover physically from that, thanks to my very supportive family and friends and a great medical team. But it was one of the few falls, really, that canopy researchers have taken. It's been remarkable how in the course of the last 40 years of canopy research, there have been remarkably few accidents or falls, either because of the tree or the equipment. Mine was due to the equipment. My rope actually failed. So there's that danger all the time. But I think as, like race car drivers who put themselves in these situations where like, it's super dangerous, you're always really paying attention. And I think there's always this sense of, when you're in the canopy, although you're enjoying the beauty and the diversity and everything, all the sense of longing being fulfilled, you're also really aware always that I am 150 feet above the forest floor. So we take enormous care with our equipment, with always working with another person, with radios, with first aid kits and rescue techniques. One on the team is always expert and licensed in climbing and climbing rescue. So I think that's, and paying attention. And I think very often, it's when I drive to a field site, when I'm on the freeway, listening to a phone call or putting my lipstick on or whatever, that's actually a lot more dangerous than climbing a tree, because we're not paying attention to the potential dangers that we're encountering as we speed down this giant 60-mile-an-hour highway. So there are dangers, but again, as with any profession or any hobby or any sport, there are ways to take care of ourselves.
Hey everyone, that's a great stopping point for the first half of our conversation. Come back next week to hear Nalini talk about her extraordinary public engagement work, including her work with prisoners and religious communities, as well as her tussle with Mattel after she created Treetop Barbie. To make sure you don't miss it, subscribe to our podcast if you haven't already, and please leave us a review. We'd love to hear what you think about the show.